Welcome to the Business Analyst Pandit channel. My name is Ram Prashant Vishwanathan, bringing you the latest industry trends and innovative insights straight from the minds of the experts. And today we have Ashwin Ramachandra on our show, who needs no introduction to Tata Elxsi, and he's the Director of Technology of Transportation Business Unit from Tata Elxsi. Welcome to the show, Ashwin.
Good morning, Ram. Very pleasure talking to you as well. Thank you so much.
Pleasure meeting you. Thank you so much for being a part of this show, Ashwin. Ashwin, I have an interesting topic for you today, which is demystifying the software-defined vehicles. And before we demystify SDV, can you please introduce about yourself to the larger viewers here?
Sure. My name is Ashwin, based in Bangalore, working with Tata Elxsi for a little over 3 years. I am currently looking at technology and roadmaps for the transportation business unit. Prior to that, I have about 23 years of experience in embedded technologies across semiconductors, mobiles, etc. A whole bunch of stuff that I did in the past. So yeah, very, very quick. Yeah.
Nice knowing you about you, Ashwin. So to begin our conversation today, Ashwin, what is software-defined vehicle and how are software-defined vehicles are different from the traditional connected cars?
Sure. Actually, let's start by looking at it from two perspectives. Perspective of a technologist, which we will cover a little bit later, but from the perspective of an actual user. So if you look at it from a perspective of a user, and if you had, let's say, two cars parked next to each other, right, an SDV designed car and a regular car that is, a non-SDV based car, from the outside, you couldn't tell any difference. It would just look the same. And if you got in again from a user perspective, it would pretty much drive and feel exactly the same. So you really wouldn't be able to tell the difference. Where from a user perspective, the difference comes in is that the feature set of a non-SDV based car is frozen. It is static. You won't see any new features coming in as you start continuing your ownership experience. However, with an SDV car, what will happen is that you will have the option to get newer features as your car ages, right? So this is something new. It's probably never happened before in the automobile industry. Typically in the automobile industry, once you buy a vehicle, the feature set you get with the vehicle is that's it, right? It's frozen. That is the significant change from an end user perspective, the ability to have a set of features on the vehicle that you're owning, which kind of keeps on refreshing and you're getting the ability to get newer and newer features, right? So that's from an end user perspective. From a technologist perspective, I think it's pretty exciting because there is a significant, it's an inflection point in the automobile industry. We're looking at a complete redefinition of the electrical architecture. What used to be several control units running bits and pieces of software for each function within the car. A lot of that is coming together with the intent of consolidation, with the intent of having a more optimized architecture and cost structure, etc., which enables a lot of the fun stuff that I described in the first part of the thing, right? So that is what we should look at it from a technologist perspective. So it's important to appreciate it from both perspectives.
Got it. Agreed. So Ashwin, traditionally, cars have relied heavily on hardware. How does an SDV differ in terms of the hardware-software relationship?
So nothing changes from that perspective. The idea is that still, of course, you will have everything else, like, for example, the engine, be it an internal combustion engine or an EV, right? So you will have a drivetrain that remains the same, etc. You will have an infotainment system that remains the same. You'll have your ADAS or driver assistance features that remains the same. But really, the critical part is what we talked about a little bit earlier. The idea is consolidation. In current generation cars, the infotainment is a standalone piece or a silo. The ADAS system, the driver assistance system, is a standalone piece or a silo. It's a separate piece. Your body and chassis control would be yet another separate piece, and it would be siloed, right? So you would have these independent silos and therefore independent pieces of hardware and independent pieces of software that are somehow talking to each other, that are networked and are talking to each other in the current generation of cars. From a hardware perspective, when you move into an SDV, we are looking at a high performance computer or HPC, which is capable of running, of a lot of compute power. So the idea now is that from a hardware perspective, you consolidate a lot of these really small computing devices, and therefore, hopefully, you create a platform that enables you to run multiple different types of software workloads, right? For example, your body and chassis workload, which was an independent siloed unit, should be able to run as one of the workloads on this new HPC. Same thing with your driver assistance algorithm, same thing with your cluster, same thing with your infotainment. So from a software perspective, the exciting concept here is abstraction, a lot of reuse possible, plus the ability to actually continuously provide new and refreshing features for the user, right? So we're looking to move towards a HPC, abstract the concept of the HPC to a certain extent from the software, and have the software continuously evolve. So that's how we should look at it.
Got it. Okay. So, what are some of the key advantage that an SDV offers over a conventional vehicle for car owners today, Ashwin?
Yeah, so we already talked a little bit about that already. Number one, the most important thing literally is the fact that when you buy your car, the feature set that you have on your car, which is an SDV oriented or it's an SDV defined car, will possibly be the least, the smallest possible feature set, and you will have the ability to get newer and better features as the car ages. A year down the line, 2 years down the line, you will have the ability to get newer features, which just doesn't exist. Now, the ability, why do I say the ability? The reason is that it could be two or three different mechanisms in which you can get this. Number one could be the OEM or a third party might be able to give you the feature free of cost in return for something, obviously, possibly your data, maybe the access to your data. Or the OEM or the third party might be able to give you the feature as a subscription. So you could actually get that feature for a short period of time, or you could have it on a continued basis as well, right? So which is why I say you have the ability, and not necessarily that all features that are available will be automatically available to the end user. There is a concept of subscription because obviously this platform needs to be monetized as well for the OEM, and these are avenues for monetizing for the OEM.
Absolutely. I truly agree with you on this part of subscription framework and model. So, as SDVs rely more on data, and when it comes to data, security is paramount in software defined vehicles. How are SDVs addressing the potential cybersecurity risk, Ashwin?
So cybersecurity continues. The concept of cybersecurity is really new for connected vehicles. So if you sort of look back about 3 to 5 years ago, vehicles were hardly connected. They were independent pieces of machinery that were moving that almost had no connectivity to the internet, except perhaps as an aftermarket fitment, right? But if you sort of look forward 3 to 5 years from now, a lot of the vehicles will be default connected or will have the ability to get connected based on the fact that you buy a subscription. Uh, which basically means that the moment you are connected, you become susceptible. The moment you have an IP address, you become susceptible because 95% of folks use it for good, but there's always 5% who actually want to try and take advantage of that situation, and then look at not necessarily good uses of the fact, right? And so therefore you become susceptible to hacking, to a bunch of attacks, etc. Right? So the standard principles that we would use to protect any asset, like your mobile phone, like your laptop, etc., would carry forward into the automobile industry as well. So cybersecurity in the automobile industry is evolving and is coming to terms with the fact that a car can now get hacked. Right, the concept of a car getting hacked was unthinkable, like probably 5 years ago. Whereas the concept of your phone getting hacked or your laptop getting hacked is very real, and you actually, we see this on a daily basis. But the automobile industry is now coming to terms that the car as an entity can also get hacked, and therefore, right from design principles, you have to now start thinking about it from a design perspective. Look at security as an aspect, cybersecurity and safety as an aspect from the design principles at the implementation stage, and subsequently also prove to the regulators that you have taken all the steps to essentially protect the asset and the data that comes alongside the asset. So there's a process way of doing this whole thing and an implementation way of doing this as well.
Got it. Okay. And can you walk us through the development process of an SDV? So, what are the key challenges that needs to be taken into considerations while developing a platform for a software-defined vehicle per se?
Sure. Obviously, the first thing is that you're trying to create a platform that spans across, let's say, a bunch of architectures, right? HPC architecture. So there's obviously a sense of abstraction that needs to come in over there. So we're looking at a compute platform as against an individual, sort of a custom or a purpose-built platform that used to happen in the current generation. So we have to look. We consider the fact that abstraction is important. So therefore, you have to sort of look at a framework that abstracts everything from a hardware perspective and provides a uniform compute environment with mixed criticality, right? So an environment or a development environment that enables the fact that you can have mixed critical workloads is important. So that is going to be a critical step or an aspect as part of the development process for an SDV vehicle. It's the reason again. Let me just sort of double click on that a little bit. The point is very simple. You have one HPC, and that HPC can run, let's say, an infotainment workload, which is deemed as QM from an ASIL perspective. It can also run some, let's say, driver assistance workloads, for example, driver monitoring, cabin monitoring, lane departure warning, etc., which are typically ASIL Bravo workloads or ASIL B workloads. All of it is running on the exact same, compute system. Like I said earlier, there would be independent and distinct systems, siloed systems, but now it's coming together on a single HPC. So the development environment and the development processes need to take care of this. The fact that you are sharing your compute environment with mixed critical workloads is important. So that becomes an important aspect as well. Validation, therefore, becomes an important aspect because now you're not validating a siloed system, but you're actually validating a mixed critical system. So even from a validation perspective, that becomes it becomes fairly important to consider that right at your design phase itself. So I mean, we could go deeper and deeper into it, but that's a quick overview as to how things will change.
Absolutely. I agree on this part, actually. Probably we should have another session to deep dive into the challenges as well. So, coming back to the challenges, I would say, so what are the biggest hurdles uh, to the widespread adoption of an STV? How can we overcome these challenges? If you
I think
could give
it's
some
new,
touch
number
points.
one.
Yeah.
Sure, yeah. It's new. The technology is new. As I said, the automobile industry is at an inflection point. It's a significant inflection point because we are moving from siloed independent systems to a HPC or a central and a zonal kind of a system. So obviously, like any new architecture that comes in or a new paradigm that comes in, it requires acceptability. It requires proving. The fact that you can actually run mixed critical workloads needs to be proved and then certified before we can get vehicles on the road. So there is a large R&D cycle that is involved, which we are going through now, and Tata Elxsi is, sort of is a leader in this space, and we are working on programs that enable this. And I think the R&D phase is the huge thing. Like anything new coming into the market, we have to get past that R&D phase and actually prove that this entire concept works. That would be, I think, the single biggest challenge. But if you get past that, we're looking at cost optimization. Ideally, it should actually mean that once SDV is fully adopted at scale, you should see a certain amount of optimization of costs as well. Once you've gotten past the initial R&D investment that's required to make that happen. So that would be a quick overview of what we would need to look at over the next 2 to 3 years in terms of challenges.
Perfect. So, looking ahead, what exciting possibilities do you see in software-defined vehicles in the next 5 to 10 years?
Clearly, I mean, the fact that we have centralized compute and zonal enables a bunch of use cases to be unlocked and made available to the end user. So really, enrichment of features, feature set based on personal choices. So I could have the very same car, and if I have three members in my family, I could have three different configurations, including feature sets that would come in. And the car, because of the fact that you would have driver monitoring systems, etc., would recognize who's the person who's driving and automatically configure that set that person's preferences and that person's application suite, that person's subscriptions in the car, right? So that's something that's unheard of today. If family members or people are sharing a car, it's the exact same car that goes around, right? You really cannot. There's very little with respect to personalization that happens at this point in time. But that is going to change. We're going to have possibly an extreme hyper personalization that will happen within the same vehicle, radical sets of subscriptions and features that would change depending on who's at the wheel, depending on who's in the passenger seat, what is the kind of subscriptions that person might want, etc. Including the option of having a guest come in and bring in their subscription for a short period of time if they're sharing a ride, right? All of these suddenly become feasible in the future.
Got it. Okay. But developing an SDV platform and a framework likely requires an expertise across various fields. So, how do you think Tata Elxsi approach collaboration with different stakeholders?
Absolutely, yes. This is new stuff, cutting edge technology, and Tata Elxsi has been always investing and making sure that we have a very strong point of view. So to that end, we have Tata Elxsi has invested in its own framework. It's called Avenir, and you could look it up. It's available on the web as well, which spans across each of these things that I talked about: a cloud native development environment, a validation environment, which becomes important, the middleware, which enables all of this mixed critical compute, a subscription framework, and finally a connected vehicle platform as well, which you are very much a part of as well, right? So we're looking at the entire spectrum of this, that we are bringing to the market. We believe we have an edge out here. It has been validated as well because of the kind of conversations and the engagements that we have. And so, yeah, I think we're very confident about the fact that we're on the right track with our investments with respect to what we're doing in this space.
Rightly said. So, one last question before we conclude this episode. And for the viewers interested in pursuing a career in technology, in this technology, so what advice would you like to recommend, Ashwin?
Uh, Automobile technology is exciting. It's always been exciting, and with this inflection point, it's going to become even more. So I would encourage, and given the fact that there are inside an automobile there are safety critical systems, I would encourage understanding of these safety aspects of an automobile, and then figuring out how you can have mixed critical systems running on a HPC, right? So these would be aspects that we would look at. From an end user perspective, think about how you can develop interesting use cases for the end user, and it could be in conjunction with an OEM, or it could be by yourself as a third party as well. So the future is exciting. It provides lots and lots of opportunities. I would really encourage for anybody who's willing to invest in a career out here to start from understanding the automobile basics, understand and appreciate that security and safety is involved, and then build up on top of that particular understanding.
Got it. Ashwin, thank you so much for taking time to share your insights and for the engaging conversation we have right now. And I wish you all the best, and I look forward to connecting with you in another episode. Thank you so much.
Cheers. It's been a pleasure talking to you, Ram, as always. I look forward to taking this forward as well. And good luck and cheers to you as well. Bye.
Absolutely. Thank you so much. Have a nice day.